Thus, in this video, we will see the next question from our LeetCode 75 list, and it is a question which you will find might difficult, but someone find it very easy. Depends on how much backtracking you understood and how much you are comfortable with it. So let's go to the question first. And now, this is the question, which is combination sum 3. So what question says that find all valid combination of k numbers such that sum up to n such that the following conditions are true. One number 1 through 9 are used. Only 1 to 9 number are used. Each number is used at most once. Return a list of all possible valid combination. The list must not contain the same combination twice and the combination may be written in any order. Okay. So basically what they are saying कि the list must not contain the same combination twice means this is the first example that I picked here, and this is the combination they have given. This one and this one is same. We just rearranged that number. So you need to understand this कि whatever the numbers we are taking in that vector, that combination should be unique. Okay. So basically you can imagine as a set of number in which if you enter number in any order, there will be in increasing order in, and yeah, if you do it multiple times it will reject it. Likewise, if you have a multiple sets, like same set, you can say set 1 to 3, set 1 to 3, set 1 to 3, and if you enter those set inside a set of sets basically, then it will store just one time, right? So basically that what it means कि we just want a number combination just one time and we don't want its rearrangement again. Okay, 214 is nothing but the rearrangement of 124. Again you can rearrange it like 142, 1412, 421, like which we can rearrange it, but all those means just one thing कि the numbers are the same, so it's a one combination. Okay, so yeah, the size of that vector should be k. Okay, the size you can see that here is 3 size and they have said k is equals to 3. Okay, and sum should be n. So 1 plus 2 plus 4 is equals to 7. That's okay. So how we can solve it using backtracking? So let's think about what first number you can take in a vector from 1 to 9. Any number I can take, just that number should be less than n, right? That what I'm saying कि here for n is equals to 7, I can take a number from 1 to 7. I can take 8, right? Cause it itself a greater than 7, so we can't think about to take 8 and take number to add up and to get some n. So we can take 1 to n. Okay, so that condition I'm getting now कि I should add a number in a vector if it is less than n. Okay, then I'm just thinking about a one vector. Okay, inside that vector I can take number, that this number should be less than or equal to n, and what I can take that number when the size of that vector itself is less than k, right? Because when it is k, we should see the sum is n or not, and then we should take that in our answer, right? So size should be less than k, and the number which we are adding in that vector should be less than the n. Okay, so let's think about, I have k is equals to 1 and n is equals to 1. Okay, so here how many combination can we form? Just one, right? 1 1. I can take 1 and whose sum is 1, right? I can take, like if it is 1 to 9 and I just allowed to take one number, then I can take just this one, like the size of that answer vector will be 1. Answer of 2D vector will be 1. Here it will be n only, right? Because it's k is equals to 1. Now think about k is equals to 2. That time what I will do, if n, now I can increase the n, like if let's say if I take n is equals to 1, can I take any, like do I have any answer for this? No, I can't have. Why? Because there is not any two numbers whose sum is equals to 1. Do you have, like I'm saying, a number which start from 1, not from 0. Number who start from 1, and we need to take those two numbers whose sum will be 1. Yeah. Is it possible? No. In that case, what we will do, we'll just return empty vector. Okay. We don't have any vector inside it because we don't have any combination. Okay. So now take n is equals to 2. Only one combination is there. Which one? 1, 1. Right? So we can say it is 1 and 1. So let's say I just took 1. Let's say I'm at answer step. I take 1 and okay, n is equals to 2. Then what number I can take now? 1. Because you know, I know, because we saw here I took 1. But how will algorithm know that you already took 1? Do you save it in set, and every time when you will add that number inside a vector, you will check this this exists in set or not? This will take too much time. So what we can do here, so when you add that number in a vector, at that time what you can do, that you just subtract that number from the n. I took 1, so subtract that from 1, like 2, now it's 1. Next time what I can say, ki it's, and also size. Now k is equal to 2. For the next step, how many number I can take? Only 1. You know, me know, cause we can see. But for the algorithm, we need to record it somewhere, right? We took 1 number inside our vector, so we just need to, what we need to do, I took 1 number, any number I took, so next time I will took 1 number less. And then after next time I'll do 2 number less, after next time 3 number less, like how, like the deeper I go, that depth I am doing minus in the inside k, like from k basically. So next time k will be 1 and n is equals to 1. I have one option only, that I have to insert 1, right? So here you have observed that at every time when I am going ahead, I am just what I am doing, ki what number I took, that I am subtracting from n, and I took 1 number, so the size should be increased by 1, and I just storing in a vector, and to just know further, and to just know the combination further, like how many numbers I want, I'm just subtracting 1 from k, so that in next step what I want I'm let's say I'm at first step, and like at the root, like I don't have anything, I'm going to the next step. Okay, I don't have anything, I'm going to the next step, and I'm taking something from now, and for the next step I want k minus 1 numbers. After that step I want k minus 2 numbers. Likewise, at every step, if we see one number is increasing, so what we can do, at every step we just minus the, if you take one number, I need to minus that one, like not that number, I just minus 1 from that k. I think recording stopped. 1 minute. Yeah. So yeah, we now you understand that at every step we just do my k minus 1 and n minus the number we took. And okay, that you understand. But when we add that this vector to our answer vector, when now at this step I took 1, now I have to do minus 1 from here and from minus 1 from here, so it will become 0, and this will also become 0. Now you understood that when k is equal to 0 and n is equal to 0, at that time I need to add my this vector to my answer vector. Okay, something also more can happen. What? Like this number, whatever I was storing, that also should be stored somewhere. So let's say, let's take some more different example. K is equal to 2 and n is equal to 9. Here, let's say I need to store, like I need just take one variable to store a number which I am storing in a vector. So num is equal to, I am taking 1 right now. Okay, num is equal to 1. I took 1 is less than 9, so take it, and then go further. And after I am going further, I am just reducing 1 from it, and I took 1, so I am just reducing 1 from 9, which is now 8. Okay, now I can put, now I'm at 1 only, and I took 1, so I will say ki take nums from 2 now, because I take 1. So take 2, and now I can say ki, okay, 2 is less than n, 2, and yeah, I can add it. I add it. Then I can say ki, yeah, its size is n, its size is k. When I added it here, when I did -1 from here, and here it will be just 6. Okay, so what I can say ki k is equals to 0, but n isn't 0, right? So here what I can say ki when k is equals to 0, just return, k is equals to 0 and n not equal to 0, just return, cause there is no point to go further, cause my vector sizes will increase and I don't want that. I just want k size vector. Okay, so what I will do, I just wanted to tell you that condition, so I just pull this move. Okay, so whatever I told you, we need to write that in code. While writing code, you will definitely understand what I was saying throughout that time. So yeah, let's go. Let's write the code. We have vector and vector int answer. I have vector int for, I can say ki this is the vector v, which I will insert in my answer. I will solve it. As I took number, I will take, okay, start from number, and I can say ki my identity num start from 1. Okay, then I have vector v, and then I have my answer, and the size should be k and n that I took from here just, and return my answer. Okay, so let's write this function. This solve function is nothing but the DFS that you will understood here while writing the code. Okay, and this will be the void one, cause we are just returning, we are not returning anything, like not any int or any vector, we are just returning this num. Then we have vector int, then we have answer. Here the answer will take as address of this, cause we are returning it here and we want that to be stored, and int n and int k. Okay, so first what we will do, if my number, okay, no, what I will say, if my k is equals to 0, that the first condition we discovered, that if my k is equals to 0 or my n equals to 0 and my n equals to 0, then what I will do, my answer dot pushback v, and just return pushback v and return from here. Okay, this condition we need to see ki, okay, k is equals to 0, n is equals to 0. Then what if my num is 10 now? I am just going ahead, and right now my num is 10. I can't take that now 10, right? Cause we just want till 9. So if my num goes out of bound, we can say we can take 9 till 9, max 9 number, and if it is 10, I can't take that. I have to return. Then okay, now what I have? What I have here, like, okay, I have vector v and I have num. Okay, while that num, like when I can add that num inside a vector, when that num is itself less than or equal to n, that we discussed. If it is less than or equal to n, then add it to the vector v dot pushback. I can say v dot pushback, add that and go ahead. Okay, solve for the next number. And now solve for the next number, v answer and k minus, I can say, I can do here k minus what, 1. I took one number, and k minus a number, not k minus number, it is n minus number that I took right now. And what I have to do, I just after solving everything, like when I will return, I have to, like, I explored combination by after taking that number. Now I don't want that number, I will take the next number. So I will say ki just pop that out, pop back. Okay, now what I have to do, now I have to just do num plus plus. Why? because I explored with this number, but I need to explore with next number, right? So I will do num plus plus, and yeah, that's it. Just run it. What happened? Accepted. So just submit it. Wrong answer at this. Why? We took 17, 16, but we did that right here. But here we didn't. And num should be less than 10. Then do it. Now submit it. Yeah, done. So yeah, this was the condition that remained, that we are taking num, so we need to check it key if it is less than 10 or not. So yeah, how much space did we use? This was the required one. We just use this one, so big of n, that big of k you can say, because that's the only thing, that's the only size we are using. And what, this is the required one, so I'm not considering this. We just used this one. And what, yeah, the size is like space complexity for this is big of k you can say, and time complexity for this is, you are exploring at every point, right? Here you are going from num to n, and here you come to num, and here num to n, so num cross num to n, num to k. So basically it is just to like from num to 9. So it is not like I can say ki yeah, this num we are taking, and this one, the size is not more than 9, and this one is 9, so we can manually calculate it, and I can say ki is time complexity is big of, arey yaar, big of constant, if can, cause we can constant, for that I will write k, here I will write small k, cause we can calculate here. N can be till 60 and k can be till 9, and the max complexity we can calculate here. So yeah, from here also we can calculate that if num into num to 9, here we are going, and that start, this will be nothing but the for loop, right? And we are entering in this for loop from that, from this num, so num cross num into 9. So yeah, so instead of this we just will take, it is the constant one that we can calculate from the highest one here. Okay, so that's it for guys, we'll meet in next video. Till then, bye bye. Don't forget to subscribe.